Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto, and I want to explain example 8 of Pure Mathematics 2 on page 55. Even as we get to the end of the topic, we need to understand a few things, and we must remember that we have outlined the laws of logarithms in a previous video, and the laws of logarithms are the ones which are going to be applied here. And the question is, write in terms of log to base a of x, log to base a of y, and log to base a of z the following. Of course, if you look at this, it is mixed up. X, y, and z are in the same term, or they are all multiplied together, but we are supposed to write them separately. This is in the form of course, we need to separate the three variables, each one of them with a log to base a, and this one is because they are multiplied together, we apply law 1, and you're going to have log to base a of x squared plus log to base a of y plus log to base a of z cubed. And at that point, you would be able to realize this one now simplified because it index is one index, and to apply now with the index law or the power law, index becomes a coefficient. Finally, to have log a of x plus log to a of y 3. That is how we should write that. If you look at b of the same, having log a of x over y cubed, and this one is just we should use law 2, which talks about subtraction. Every time we are dividing and we are using logs, we should remember that we should be able to subtract the logarithm of separate variables. So this is log a of x minus log to base a of y cubed, and of course for this one it has to be, this index has to be a coefficient, so this one goes without saying. This is log to base a of x minus log to base log a of y, and that is the final submission as far as that one is. Part C, we're talking about log to base a of x root y, everything over z. There is a numerator and there's a denominator, and numerator is already in product form. So in an attempt to separate this, you're going to have log to base a of x root y. We first of all separate the numerator and the denominator, minus log to base a of z. We have now pulled the denominator apart, and of course we can see there is a multiplication of x and root y here, so it continues to be log to base a of x plus log to base a of root y minus log to base a of z. having reached there, of course, we can rewrite this one in terms of power. So this is y raised to power half. And in attempt now to write it in the final way or in the final format, we're going to have this one is equals to log to base a of x uh, plus a half, because this is y raised to power half. That index becomes a coefficient according to the power law of logarithm. Log to base a of y minus log to base a of z, and that is just like the final submission as far as that one is concerned. Part D, we have log to base a of x over a power 4, which is the same as log to base a of x minus log to base a of a raised to power 4. Because there's division, we have to subtract the logarithm, and this one is going to be affected by the index law, and we have like log to base a of x minus 4 log to base a of a. But you have to be very keen here. There is something cropping up, something which is very interesting, that we are ending up with log to base a of a, which is obviously a 1, and 4 times a 1. So we have our final expression to be log to base a of x minus a 4. Log to base a of a is 1, and of course that is the final expression. So please take care and learn how to apply the laws and keep them somewhere so that you can just remember them easily. All right.